So special triangles, we have two types of special triangles. The first one is 30, 60, 90 degree triangles. And the second one we'll discuss is a 45, 45, 90 degree triangle. These are common triangles or common degrees that we're going to be dealing with a lot in trig and pre-calc. And what we want to learn here, it's actually a shortcut, so we don't have to do a lot of trigonometry. Once we recognize that we have a 30, 60, 90 triangle, I'm going to tell you right now, the ratio of sides is 1 to radical 3. And my ratio of sides for a 45, 45, 90, well, if these two sides are the same, or rather if these two angles are the same, these two sides are the same, so we're going to call this a 1, 1, radical 2. That's the ratio of sides in these two special triangles, which means it's a ratio, so we know that in a triangle, let's look at a 30, 60, 90. Right? A 30, 60, 90 triangle, no matter how big the triangle is, the angles inside always have to add up to 180 degrees. So I could have a 30, 60, 90 triangle that looks like this, and another one that looks like this. So the ratio of sides, 1 to rad 3, we could call this 1x, 2x, and x rad 3. Which means if my smallest side, your smallest side is always across from your smallest angle. Smallest side's across from your smallest angle. Your largest side is across from your largest angle, and your middle side or medium side is across from your medium angle. So if I had this example and just say my smallest side was 5, right? This is all the information I need to solve this triangle, right? As soon as I see this is 30, I know this has to be 60 because these are complementary angles. I know this is a 30, 60, 90 because it has to add up to 180 degrees. And if the smallest side is 5, well, then the largest side is 2 times 5. The largest side is 10. And if the largest side is 2 times x, if x is 5, well, then this is 5 times rad 3, or 5 rad 3. So we don't have to use a lot of trigonometry. As long as we recognize a 30, 60, 90 triangle, we can fill it in pretty quickly. It's 1, 2, radical 3. So if this side is 8, right, I know right away, then this has to be 2 times 8, 16. And this has to be 8 times radical 3. So I could easily solve a 30, 60, 90 triangle as long as I recognize it as a 30, 60, 90 triangle. And I realize the ratio of sides is 1 to radical 3, right? 1 should always be across from my 30 degree. 2 should be across from my 90 because that's my largest. And rad 3 is across from 60 degree angle. So 1, 2, radical 3. So in sometimes in my class, I'll say, I'll get a question and it will say, find all the sides of the 30, 60, 90 triangle if the largest side is 7. If the longest side is 7, find the remaining sides of a 30, 60, 90 That would be a question I would propose. And then how you should go about solving this. Well, if my longest side is equal to 7, my longest side, this is an equation, my longest side is represented by 2x. So I know 2x is equal to 7. And then if I divide both sides by 2, I know x is equal to 7 over 2, which is 3.5, but we'll leave it as 7 over 2. So I found the smallest side. X is always my smallest side. And now I know my longest side is 7. I know my smallest side is 7 over 2. Therefore, the medium side would have to be x rad 3. So it would be 7 rad 2 rad 3. Or 7 rad 3 over 2. So you'd be able to solve that triangle. And you could do it for any of the sides. So if I asked what is the, if I gave the medium side, you would do x rad 3 equals 7. You'd solve for x, and that would give you your smallest side. And then once you have your smallest side, you could find anything because your smallest side is x. All right. Let's look at a 45, 45, 90. Come on. So we said in a 45, 45, 90, the ratio of sides is 1, 1 rad 2, right? Well, we could say this is 1x, 1x, and x rad 2, right? So whatever these legs are, right? If I let this leg, if I know this is 45 degrees, and I know that this is 8, right, then I have enough information where I could solve this entire triangle. Well, if this is 45, then this has to be 45, right? Because they're complementary angles. They have to add up to 90. And if these two angles are the same, these two sides are the same. So this would have to be 8. And if this is 1, 1, we know the ratio is 1, 1 rad 2. So I know this is going to be 8 rad 2. Okay? And if you wanted to prove it to yourself and you don't believe it, you could use Pythagorean theorem, right? You could say, well, let's check it. A squared plus b squared is equal to c squared, right? If this is 8 squared plus 8 squared equals c squared, right? We want to see if we get 8 rad 2. So this is 64 plus 64 c squared, or 128 is equal to c squared. I take the square root of both sides, so I get c is equal to the square root of 128, which could be simplified as 64 times 2, which is 8 rad 2. So it checks. So you could believe me. It's a 1, 1 rad 2. So using what we learned from special triangles in the textbook, they ask you to evaluate. Here's 4 examples where I want you to evaluate these. Evaluate means find the value. What is this equal to? What is each one of these equal to? What's the value? So if you're going to attempt this problem, it seems vague, so fill in what you know. You know what 30 degrees looks like in a triangle, right? They're telling you it's 30 degrees. Well, if they're giving you 30 degrees, well, then you know this is 60 degrees. And if this is 60 degrees, then this is 90 degrees. So if this is a 30, 60, 90 triangle, well, then that means this side is 1, this side is 2, and this side is radical 3. So now I know all the signs. So from this 30 degrees, I was able to create that triangle. The question, or the value they want us to find, is tan of 30 degrees. Well, I know tan is my opposite over my adjacent, right? So tan of 30 degrees would be my opposite over my adjacent, which would be 1 over radical 3. And we try not to leave a radical in the denominator, so we would rationalize that denominator. I'm running out of space here. We'd multiply top and the bottom by rad 3, and the real answer is going to be rad 3 over 3. Tan 30. So I'll give you a few seconds. You want to try the remaining 3 problems? We'll see how they go. I'll give you 2 minutes. Try those. You're going to have to draw a triangle. You're going to have to do the ratio of sides, and then you're going to have to use your trig ratios. Try it out. I didn't leave myself a lot of room for this one, so all of these are going to be a little bit crammed. But I know this is 45, so this is 45. So I'm going to have a 1, 1, rad 2. Cosecant, you're going to have to think about this a little bit. Cosecant is the reciprocal of sine, right? I know, I want to write it there. I know sine of theta is opposite over hypotenuse. So cosecant of theta is hypotenuse over opposite. So it's going to be H over O. And my hypotenuse in this case is 2. So I have rad 2 over 1. So I could say cosecant of 45 degrees is equal to radical 2. Cotan of pi over 3. Well, we could look at pi over 3 a few ways. Well, I guess we'll just change it into degrees. Right? If I want to change pi over 3 into degrees, I would do pi over 3 times 180 over pi. So those are going to cancel out. I'm going to have 180 over 3. So this is really saying cotan of 60 degrees. Right? If I have 60 degrees, well, then I know it's a 30, 60, 90, or 1, 2, rad 3. And I know cotan is the opposite of tan. I know tan is from SOHCAHTOA. SOHCAHTOA. Tan is O over A. So this has to be A over O. So from my 60 degrees, that's my perspective, my adjacent over my opposite. So cotan of 60 degrees, my adjacent over my opposite, looks very similar to tan of 30 degrees, cofunction. So rationalize it. So I have cotan of 60 degrees is rad 3 over 3. Or if we put it back, cotan of pi over 3 is rad 3 over 3. And lastly, we have secant of 60 degrees. So we draw a triangle, 30, 60, 90. It doesn't matter where you put your 30 and your 60. And secant is the reciprocal of cosine. So instead of being A over H, it's going to be H over A. So from our perspective of 60 degrees, well, let's put it in 1, 2, rad 3. For our perspective of 60 degrees, it's going to be my hypotenuse over my adjacent. My hypotenuse is 2. I'm going to write it here. Secant 60 degrees, H over A. My hypotenuse is 2, and my adjacent is 1. Therefore, secant of 60 degrees is 2. So using our special triangles and our knowledge of trigonometry, we would be able to find the value of each one of these functions, the function value. Let's try one more harder one. Okay, so they're giving you sine theta equals 8 over 17, and they want you to find the 5 remaining trig function values. So this one's a little bit weird. So what we know about sine is we know sine of theta. What do you know about sine of theta? Sine of theta is equal to my opposite over my hypotenuse. So this must be my opposite, and this must be my hypotenuse. So let's draw a triangle. Right? You could put theta anywhere, but theta is an angle somewhere in here. You could put it up there, that's okay. But from this angle, whether it's here or there, from this angle, opposite that angle is our 8. And my hypotenuse is 17. So really what they're doing is they're giving you two sides. And as long as you have two sides of a triangle, you could find the third side using Pythagorean theorem, right? You could do a squared plus b squared equals c squared, and substitute these values in. 8 squared plus b squared equals 17 squared. So if we use Pythagorean theorem, we could see that we could solve for this missing side, and we know it's 15. Right? So, well, now I know all the sides. So they gave us two sides. We used Pythagorean theorem to find the remaining sides, and now they want us to find the 5 trig functions, right? They gave us sine of theta. They want cosine theta, tan theta, cosecant, secant, and cotan. So this is the easy part, right? This is SOHCAHTOA, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And then these are the reciprocals. Ho, ha. So my adjacent from theta is 15, and my hypotenuse is 17. 15 over 17. My opposite is 8 over my adjacent, which is 15. And now these are all just reciprocals, right? Whatever this is, right? 8/17, so this is 17/8. 17/15, this is, rather 15/17, this is 17/15. 8/15, the reciprocal is 15/8. So it's a lot of paperwork, but I don't think it's very challenging. I think you're able to do that. In fact, the reality of it is, in this question, I lied a little bit. They gave you sine theta equals 8/17, and they also gave you cosine theta is 15/17. So they gave you more information. I withheld some information. So if you had all that information, it would have been much easier, because then you would have your opposite, your adjacent, and your hypotenuse were all given in the original question. But they gave you too much information. I wouldn't give you all that information. All right, that's enough for now, I think. So we'll call it quits for at least this part for now.